Assalamualaikum warahmatullahi wabarakatuh. My name is Medini Syeda binti Muhammad Zamri from my curious Kanabo PE180035. We'll be presenting you how to design the inverting amplifier in Multisim in this part. In the second part, will be conducted by my other two members where they can show you the output versus input in sine waveforms where the ideal gain is -1 and -2. So to begin our study of op-amp, we will build the inverting amplifier in Multisim where the ideal gain can be expressed as -R2 divided by R1. And the inverting amplifier is traditionally drawn as like 301 where the negative terminal is above the positive terminal. But while building this inverting amplifier in Multisim, we'll keep the operational amplifier oriented in manner that has a positive terminal above the negative terminal. So the Vin is connected to the input resistance and directly to the negative terminal, and positive terminal is connected to the ground, and this is the feedback resistance, and this is the output. So we need to simulate the inverting op amp where the VCC is 12 volt and VDD is negative 12 volt, and we need to set the V into 2 volt in sine wave with frequency of 50 Hz. So here are all the components that I've already picked in advance with some time, where we have the function generator, oscilloscope to measure output and input, 2 resistor, power VCC and VDD, and amplifier as well as ground. So this is the pin number that represent the positive terminal and negative terminal. Pin 7 and pin 4 is the power, pin 5 and pin 1 is the offset, and pin 6 is the output. So now we're going to connect this positive terminal of function generator to the input resistance and then directly to the negative terminal, and then feedback resistance is going to be here, and the positive terminal of amplifier we're going to connect to the ground, and this one is going to be here. The negative terminal will be there. So now the output pin going to be connected to the resistor, feedback resistance, and the pin 4 is the power as well as the pin 7 to VCC. Okay, this one is going to be connected here where the input resistance is, and this one is going to be here to the power output. Okay, this one is going to be to the ground. Then put it a bit to this one right here, and now we're going to all our set. So going to set the frequency to 50 and 2 amplitude, and in the sine of waveform, the VCC is set to 12 volt, VDD is set to -12 volt, and then the resistor is set to 2 kilowatt, and R2 is the 4 kilowatt. Okay, now we're going to run and see the graph produced by the inverting amplifier. Okay, so now I'm gonna pause a bit. Okay, so these are the graph produced, the wave that will be further explained by my group members. I think that's all for me on how to design the inverting amplifier in Multisim. Thank you.
Assalamualaikum, my name is Fatima, and my part is to show how we get the gain equal to -2. So based on the formula, gain equal to negative R2 over R1, we assume the R1 is 2k ohm and the R2 is 4k ohm for us to get the gain -2. When we run this circuit, the outcome is from the oscilloscope show that the red line is the input and the blue line is the output. We set the scale for channel A and channel B is 2 voltage per division. Channel A is the red line, meanwhile channel B is the blue line. The output signal, the blue line, is inverted because of the effect of the inverting amplifier. The peak for the input signal is 2 volt, while the output is 4 volt. And the signal frequency for this circuit is unaffected. Thank you.
Hello, my name is Anur Ashura binti Muhammad Nur Zaki and my matric number is AE180085. So today I will show the simulation of the output versus input of an inverting op-amp using multisim when gain is equal to -1. Okay. First of all, to get gain is equal to -1, we use the same value of RF and Rin. So I just use the value of RF equal to 1 kilo ohm and the value of Rin also is equal to 1 kilo ohm. Then by substituting into the formula, gain is equal to -RF over Rin. We substitute both value 1 kilo ohm and this is also 1 kilo ohm into the formula. Then we got gain is equal to -1. Next, I will show the simulation of this inverting op-amp by click on the oscilloscope. Okay, and then we run the simulation. Okay, as we can see, this is my output where this is my input channel and another one is my output channel. So there is no difference between the output and the input channel as the value of gain is equal to 1. And then we use a probe to measure the current. Okay, so this is the current, the current value of this inverting op-amp. So that's all from me. Thank you.